Hi, hello. As you all know, I am your Basha sir. Welcome back to our channel, Maths with Khadar sir. I think mostly this will be the last video of the chapter 2 polynomials, and I will try to complete this chapter in this video. Now, today we are going to do more practice sums on polynomials, like finding zeros of a quadratic polynomial and the relationship between the zeros and coefficients of the polynomial. Now, today we are going to start the exercise 2.2 sums of your NCERT Class 10 textbook. So, the first 6 sums are here. All are about asking us to find out the zeros, and next discuss and derive the relationship between the zeros and the coefficients of that polynomial. So without late, start today's session, and the first sum of today's session is x squared minus 2x minus 8. As you all know how to find the zeros of a quadratic polynomial, nothing but first to find the zeros of any polynomial we have to equal that polynomial to 0. So x square minus 2x minus 8 is equals to 0. Now how to write that? Now here take the first term as p and the second term as q and multiply that. After that you will get one product. So whose product is minus 8, and with the product, the factors of the product, if you add any two factors you will get minus 2. So how to do that? Nothing but x square minus, see here, 1 into, what are the factors of 8? 1 into 8, next 2 into 4, 4 into 2, and 8 into 1. These are the factors. Now among these factors, which two factors will give you by adding two factors minus 2x? By adding any two factors which will give the minus 2x. See, for example, here take the 2 and 4. 2 and 4, 2 4s are 2 into 4. If you take 2 into 4, it will be what? So first write the, here what symbol is here for the middle term? Minus. So write the minus for the bigger number. So here 2 into 4, what is the bigger number? 4. So minus 4x plus 2x minus 8 is equals to 0. So here take x common, x minus 4. Here take 2 common, x minus 4 is equals to 0. Now here two zeros are here. One is outer one and one is inner one. So x plus 2 and x plus minus 4 is equals to 0. Here x plus 2 is equals to 0. X is equals to minus 2. 1 0. X minus 4 is equals to 0. X is equals to 4. Second 0. Now we have to find the relationship between zeros and coefficients of a polynomial. If ax square plus bx plus c is a polynomial, if alpha and beta are the zeros, then the sum of zeros or roots, what is that? Alpha plus beta is equals to minus b by a. So what is alpha? First one minus 2 plus, what is second? Beta second 0, 4 is equals to, what is the coefficient of x? Minus 2 minus 2 by what is a? What is a? 1. So here minus 2 plus 4 is equals to how much? Minus 2 plus 4 is equals to, minus 2 plus 4 is equals to 2 is equals to minus into minus plus 2 or else plus 2. So anything divided by 1 is equal to same. So 2 is equals to 2. So this is proven. Next product of zeros. What is product of zeros? Product of zeros, what is that? Alpha beta is equals to c by a. So what is the first 0? Minus 2 into what is beta? 4. And what is the constant term here? Minus 8. And what is coefficient of x square? A. That means 1. So minus 2 into 4 minus 8 is equals to, anything divided by 1 is equals to same. So the product of the zeros and the sum of the zeros and the zeros of that polynomial is equal. So this is the first problem in exercise 2.2, first Roman. Now the second sum is 4s square. The second sum is 4s square minus 4s plus 1. Same as solution given 4s square minus 4s plus 1. To find the zeros, equal the polynomial to 0. 4s square minus 4s plus 1 is equals to 0. Now what are the terms? Here 4 into 1, 4. So write the factors of 4. 1 into 4, 2 into 2, 4 into 1. So now by adding any two factors, by adding which two factors will give minus 4s? Obviously the 2 and 2. So 4s square minus 2s plus 1 is equals to 0. If you see this, minus 2 into minus 2 plus 4 and minus 2s minus 4s. Now take common 2s here. 2 is here. 2s is left here. Sorry, 4s square s 2s is left and here 1. Next here also what? Here also take what to take? Here also take 1 common and 2s minus 1 is the inner term. Now here we have two zeros. What is that? First one is inner zero and one next one is outer zero. So 2s minus 1 is equals to 2s minus 1 is equals to 0. 2s minus 1 is equals to 0. 2s is equals to 1. S is equals to 1 by 2. This is 1 0 and second one also same. 2s is equals to 1. S is equals to 1 by 2. So these are the zeros. Now we have to see the relationship between zeros and coefficients of a polynomial. So for a quadratic polynomial, if alpha and beta are the zeros, then sum of the zeros is alpha plus beta is equals to minus b by a. So alpha is what here? Alpha in the sense the first zero, what is here? 1 by 2. The second one is also 1 by 2. So what is the coefficient of x? Coefficient of x is minus 4. And what is the coefficient of x square? 4. So both are like fractions. So denominators are same, add the numerators. 1 plus 1, 2 by 2 is equals to minus into minus plus 4 by 4. So 2 by 2 is equals to 1, 4 by 4 is equals to 1. So this is proved. Now next one is the product of 0. What is that? Alpha into beta is equals to c by a. The alpha is nothing but 1 by 2 into 1 by 2 is equals to constant term what? Constant term is 1 and the coefficient of x square, what is that? 4. So 1 by 2 into 1 by 2, 1 into 1 1, 2 into 2, 4 is equals to 1 by 4. So this is about the second sum. Now see what is the third sum in your class 10 NCERT textbook. 6x square minus 6x square minus the third sum is about 6x square minus 3 minus 7x solution. See, if you observe properly, what is the general form of quadratic polynomial? Ax square plus bx plus c. If you observe the polynomial which is given in the problem, is it in the form of quadratic polynomial? No. Why? Because here is x square term and next they given constant term and then x term. So this is not the way of a proper quadratic polynomial. So first write the given polynomial into formal way. What is that? 6x square minus 7x minus 3. Now same procedure to find the zeros of a polynomial, equal that polynomial to 0 and next 6x square, 6 into minus 3 minus 18. Now find the factors of 18. 1 into 18, 2 into 9, 3 into 6 and 6 into 3, 9 into 2, 18 into 1. By taking which two factors, by adding which two factors will you give? Minus 7. Minus 7. Now here take 2 into 9. Take 2 into 9. So what I said? Write minus symbol for the bigger number. What is the bigger number? 9. So 9x plus 2x minus 3 is equals to, sorry, here take like this. What is that? 6x square plus 2x minus 9x minus 3 is equals to 0. So here take common 2x, 3x plus 1. Here take minus 3 common. Here 3x plus 1 is equals to 0. So there is two zeros, one is inner one and one is outer one. So write the outer one first, 2x minus 3 and next one is 3x plus 1 is equals to 0. So here 2x minus 3 is equals to 0, 2x is equals to 3, x is equals to 3 by 2. So this is the first zero. and second one is 3x plus 1 is equals to 0, 3x is equals to minus 1, x is equals to minus 3. This is second 0. Now see the relationship between the zeros, and coefficient of a polynomial. So first, sum of zeros, alpha plus beta is equals to what? Minus b by a. So what is the first 0 here? 3 by 2. And what is the second 0? Minus 1 by 3. So now what is the constant? Sorry, what is the coefficient of x? What is the coefficient of x here in the given problem? Minus 7 by what is the coefficient of x square? That is 6. So here to add this both, the denominators are not same. To make denominator same, we should take the LCM. So here the LCM of 2 and 3 is, the denominator's LCM is 6. So in 6 table, so 6 in 2 table how many times? 3 times. 3 3s are 9 by 6, plus into minus. In 6 in 3 table 2 times, 6 in 2 table 6, sorry, 3 in, here what is the LCM? 6. 6 in 3 table how many times? 2 times. So what is that? 2 3s are 6 and 2 1s are 2. So minus into minus plus 7 by 6. So 9 minus 2 is 7 by 6 is equals to 7 by 6. So sum of the zeros is proven. The zeros and the coefficients are equal. Now product of zeros, alpha into beta is equals to c by a. What is alpha? 3 by 2 into what is beta? Minus 1 by 3 is equals to, the constant term is minus 3 by what is the coefficient of x square? 6. So minus 3 into minus 1 minus 3, 2 into 3 6 is equals to minus 3 by 6. See, both are equal. If you simplify this, it will come as minus 1 by 2 and it also minus 1 by 2. So the product of the zeros are proven. Now next move to the fourth sum. So here what is the fourth sum? Fourth sum is also easy. What is that? The fourth one is 4u square plus 8u. If you carefully observe, this is as the last example problem, which is I think that is x square minus 3. Applying the algebraic identity, then finding the zeros of the given polynomial. So this is this is not like that. Here how many terms are here? Two terms. So the constant term is not here. So we can easily take common. So how to do that? So we have to equal this polynomial to 0. Why? Because you are finding the zeros. So 4u square plus 8u is equals to 0. So if you take 4u as common, here u is left and here 2 is left. So it is equals to 0. So how many zeros are here? One is outer one, another one is inner one. So 4u is equals to 0, u plus 2 is equals to 0. 4u is equals to 0. So u is equals to minus 2. So these are the zeros. Now relationship between zeros and coefficients of a polynomial, that is first one is what? Alpha plus beta. Alpha plus beta is equals to minus b by a. What is alpha here? First 0 plus beta minus 2 is equals to coefficient of x. What is that? That means 8. Minus 8 by what is the coefficient of u square? 4. So 0 plus minus 2 is equals to, here 8 in 4 table how many times? 2 times. What? Minus 2. So product, some of the zeros are proved. Next, product of the zeros. What is that? Alpha beta is equals to c by a. So if you take alpha, what is alpha here? The first 0 is 0 and the beta is minus 2. So constant term is what? Here nothing, 0. So what is the coefficient of u square? 4. See here, if you multiply any number with 0, the product is 0. So if you divide 0 with any number, the answer also 0. So the zeros and coefficients are equal or not? So this is what the relationship between the zeros and coefficient of a polynomial. Now let's move to next problem, which is fifth problem. See, fifth problem fifth problem is same as the last previous example, the first very example, that is by applying the identity, algebraic identity. See here, what is the t square minus 15? So solution, if you see any polynomial like this, easily apply the algebraic identity and solve the given one. So t square minus 15, 2, find the zeros, equal this to 0. Now t square minus 15, it is looking like, right, a square minus b square is equals to a plus b into a minus b. So how can you write t square? Can you write 15 as root 15 square? That means, what is that? T plus 15 root 15 into t minus root 15. Yes. So write t square, sorry, t plus root 15 into t minus root 15 is equals to 0. So 0 is t plus 15 is equals to 0, t is equals to, sorry, root, t is equals to root minus root 15, and another one is equals to 0, 2 is equals to root 15. So these are the two zeros of this polynomial. These are the two zeros of this polynomial. Now see here. Now find the relationship between the zeros and coefficient of this polynomial. So the first one is what? Alpha plus beta is equals to minus b by a. So see here, what is that? What is the first alpha? So first is 0 minus root 15 plus another one is plus root 15. What is the coefficient of b? Is coefficient b is here? No, 0. So 0 minus 0 minus 0 minus 0. So what is the coefficient of x square? 1. So minus root 15 plus root 15, 0. If you divide any number is 0, that's also 0. So zeros and coefficients of polynomial is equal. Now product alpha into beta is equals to c by j. So what is alpha? First one. Next one. So constant term is what here? Minus 15 by, what is the coefficient of t square? 1. So minus into plus, minus root 15 into root 15, 15 is equals to, if you divide any number with 1, the answer is itself. So the zeros and the coefficients are equal. So this is what the relationship between the zeros and the coefficients of a polynomial. Now let's move to the second Roman of the exercise 2.2 of polynomials. So this will be the last Roman, and after this chapter will be complete.